I'd like to quickly move on to our next speaker, who's Carsten Bormann, and he's going to speak about Wbone, WLAN roaming based on deep security. And I hope the technology is going to work this time. Carsten.
Good morning. No, the technology is not working. 1, 2, 3. Good morning. While this is being set up, you have been subjected to 2 security talks already today. We have managed to get you in here by putting wireless LAN on the title slides, but really this is all about security. And I'm going to present another talk that talks about security. But of course it also talks about organizational issues, because security only works when your organizational issues work. Thank you. So when we talk about wireless LAN security, we have a certain expectation, a certain minimum expectation of what is supposed to be available. And I think many users actually expect us to do something about privacy, about confidentiality of their traffic. And obviously, as administrators of these systems, we want to have accountability. We want to be able to find out who did something bad. So I think these are the basic requirements, and there are, of course, many ways, many solutions for the requirement. And of course, security is never easy. So when you look at this picture, for instance, you would think these 2 security experts are perfectly relaxed and happy. But if you look closer, you see what it needs to get there. So there are many approaches, actually, to getting this security. There is the access point-based security, where the access point is the security boundary. And we have just heard a talk from Klaus about one such approach. There have been others which essentially are dead. There is a new thing called WPA, which fixes a number of these issues, but probably isn't of much interest to us at this point in time. This is one set of approaches. And the other set of approaches is not to try to use the access point as boundaries, but to put boundaries within the network somewhere. And of course, there are lots of these possible boundaries. And one set of boundaries we already are using in many places are virtual private networks. Virtual private networks in the sense of security virtual private networks. I know this term is also being used for something else, which I don't mean at the moment. So most people who cared about security for a few years know about SSH, which is a very simple but very effective way of getting something that is very close to a virtual private network. Many people use PPTP or IPsec for access from the road and so on. There are lots of VPN standards out there, and one idea was to simply piggyback on that development. And if you look closer, once you have VPN security, you don't really need access point security anymore. So the architecture we essentially came up with in many German universities is extremely simple. We have one network, the docking network. This network is always red because it's unsafe, unsecure. And this is the network where all the access points sit. This is, we have a few servers in here, a DHCP server, and DNS server, and a web server. And we have VPN gateways. There is nothing else in the docking network. So when you go into the docking network, you are in there. It's very easy to get in, but it's very hard to get out because you have to go through these VPN gateways. You need these little servers here so that the PC that gets switched on gets an IP address, gets DNS access, so you can use logical names for things, and maybe get some web services to download new versions of some software or register for the service or whatever. But these are very small services, and the main purpose, of course, is going through these VPN gateways. And the good thing about these VPN gateways is you can attach them to whatever target network your users want to connect to. So in Germany, we have something which we over-pretentiously call the standard architecture, which means all the access points are in one layer 2 VLAN. This is not really necessary, but it helps with seamless roaming. We call this the docking network. That's a new term. And they usually use some specific SSID, wireless LAN SSID, just to make entering this network explicit. It's very secure, so this wouldn't be needed, but for legal reasons, it's still useful to force people to explicitly say, I want to go in there. Okay, and in this docking network, we have very little infrastructure. And for each target that users may want to use, we have one or more VPN gateways using the security policy of your choosing, using the protocol of your choosing. Within the university, we, of course, have quite diverse requirements. The research types want to have very open access. They don't want to have any firewalls. The administration types want to have very tight access and so on. We can give each of them one VPN gateway that suits their security policy. Actually, we are using PCs with Linux as VPN gateways because they are more cost-effective for us. You can also buy a Cisco VPN concentrator or some Nokia gear or whatever. But for us, the malleability of the Linux boxes is quite useful. Okay, so this is the standard architecture in many German universities. And this is essentially the basis of this talk. Now, I want to linger a little bit on the issue, which of the three approaches that we had today you should use, because I want you to go out of this room with the knowledge there are good reasons for all three of them. It's not like one is better and is going to crush away the other ones. There are good reasons why people are using the various approaches. So at the end, I will have slides about interoperability, because that's what we are going to need on the European level. Now, why was it such a success within Germany to go for the VPN approach? First of all, we all have a lot of experience with layer 2 security now, and we know that there have been a lot of problems, and the standards bodies are only slowly catching up with getting real security deployed at layer 2. So we just trust IPsec infinitely more than whatever the 802.11 committee comes up with next. Okay, but that's more like a meta issue. The really main issue is you can get VPN software for just about everything. Windows 98, PDA, PDAs are no problem anymore. So you can support the diverse culture that you would have in a university. And as I said, you can support all the security contexts that people want. Originally, we in Bremen wanted to deploy .1x, but when we started discussing with our administration, we found out that they were about to put in another wireless LAN into the administration building that then would only be accessible to administration people to make sure that they have their security requirements, which would mean that administration people would never be able to use the wireless outside of the administration building, and students and other employees would never be able to use the wireless LAN inside the administration building. So this was essentially what killed .1x for us. There is new hardware out today that allows you to assign people to different security contexts. Klaas alluded to that. So maybe today with certain hardware it's no longer that much of a problem, but it's a killer if you don't have that capability. And of course the data is secure in the air and up to the VPN gateway, so the administration person sitting in a different building can be sure that the data don't get snooped on. So the real reason is it just works. That's why you want to do VPN. Now, why do you want to do .1x? Well, first of all, as Klaas hinted, .1x is taking over the wired segment by storm, because people see that the manageability improvements by having sockets coming out of the wall that only by .1x learn what is going to be plugged into them is tremendous. So it's pretty clear that in 3 or 4 years we will be using Ethernet with something like .1x. That's obvious. Also, we are seeing some pretty promising developments in the EAP part. TTLS looks right. I mean, it's still a draft. People still work on it. And maybe at some point we actually will get vendor support, but it's moving. We get support for more and more systems. Maybe we will at some point get macOS support or support for Linux that out of the box supports the EAP protocols we want to have. And a very important reason to use .1x, the crypto work, which is processor intensive, is distributed out to the access points. So your crypto capability grows with the throughput you deploy in your wireless LAN. If you deploy 10 more access points, you get the equivalent of 10 more crypto boxes, which is nice because you don't have to buy this big one humongous VPN gateway, but of course also means that you pay for this crypto capability at the time of access point rollout. And when you want to change your crypto capability, you may have to deploy new access points. But as this is stabilizing around AES, again, next year, year after next year, this may be the thing you want. It's nice to be able to block them as early as possible, so using the access point as a boundary is attractive. With new hardware, you actually can accommodate multiple security contexts, so with Cisco 1200 and other products that have been announced, you can solve our problem that stopped us from using .1x. Okay, so the reason why people want to use .1x is that it just works. And the third approach, the web-based filtering approach that Sami and Kari talked about, this is really the killer argument is you don't need software. So you can just come in with a random box and it's just going to work. And it ties right into your existing user password schemes. You don't have to invent PKI stuff or have to make sure that you get IPsec keys out to people and so on. It's very easy to make it work for guest users, obviously, because they don't need software. And you may be able to tie in with hotspot counting schemes that are coming up, like the green spot scheme in Germany. So it's certainly something that makes you think about a wider world than just the education world. And many people argue, well, privacy on the air isn't that important anyway, because people who want privacy are going to use VPN on top of web-based filtering. And accountability isn't that important anyway, because anybody who can spoof a MAC address deserves access or something like that. So, I mean, that's subjective. For some network administrators, these items are absolute musts. For others, a certain level of accountability is okay. And since it just works, it's nice for the administrator because there is less work. Okay, so now you know that there are 3 there are going to be 3 groups of people out there in Europe that use 3 different approaches to securing their wireless LAN. Now, our users, want to roam between institutions. So we have to work on making all these 3 approaches roam, and we also have to work on being able to roam between systems of different approaches. So a .1x user that goes to a VPN site also wants service. May not be quite as easy, but we have to make sure it works. So in the task force mobility, we are looking at all 3 types of access control. But since we already had 2 talks about the other ones, I'm going to focus on the VPN part. And I'll quickly say what we did in Bremen to make this work. And if you get bored, you can look at the Terina mobility website. So let me quickly review the requirements we have for roaming before I explain what we did in Bremen. So we want to be able to give end users the capability to work everywhere, to use the internet everywhere in Europe when they go to another university or research site. And this means the administrative overhead must be very, very small, or we'll all die from the overhead. We have to have good usability, or people will just not use it, fall back to their old ways of doing things. And we have to maintain the required security for all partners. Okay, there are some slides here I'm going to skip because we are out of time. But if you download the slides, you can see what these 3 headline items actually mean in practice. And of course, when you talk about security, I promise to talk about security, the whole issue of confidentiality, of course, comes up again. Okay, there are even some non-requirements because we know we cannot protect wireless LANs because people can always mount a denial of service attack by carting in a microwave oven. So there are some things we don't really have to do that cellular operators have to do. Okay, let's talk about Bremen. In Bremen, a state in Germany, we have 5 universities, 4 of which, the first 4 on this slide, actually work together quite closely. They have joined programs of study, they have joined courses, and so on. So students actually go back and forth between those universities. And of course, each of the universities has their own little wireless LAN. So we had a strong need to get roaming going, at least within our little state of Bremen. So happily, everybody was using the VPN-based solution, which often happens in Germany. And well, we just looked at it and decided, let's interconnect our docking networks. I'll explain this in a moment, how this works. This requires a little bit of work, a little bit of routing and address space coordination, but it's not hard to interconnect the docking networks. And we were lucky, we all used different RFC 1980 networks for our docking networks, so we could just interconnect them. And the effect is that we now have this situation. This is the figure I just had with a docking network, 1 or more VPN gateways going to various networks in the institution. And in the next institution, we have the same situation again. And what we now do is we interconnect them in some form, which we call the Wbone. And this then means that this guy with their laptop can just go through this docking network, not even talk to any of the VPN gateways here, to their home docking network, talk to their home VPN gateway, get authenticated there, and get, for instance, into their campus network or get into their intranet if they so desire. So this is a very simple solution, except for the fact that you have to get this actual interconnection working. So clients leave through their home network, they get home addresses, they get all the access rights that may be available for those home addresses. So this is the structure we have at the moment. We have 4 universities and 1 research center connected to the Wbone in Bremen. And as you can see, we happen to have different, for some reason these don't show the addresses, but we happen to have different RFC1918 addresses. So we just had to find an old router that we still had sitting around, interconnected the networks, and we were done. So this was all very simple. Now, why should you be interested in this? Well, we have experience with making this work. People use this every day now. We have about 1,800 registered users in Bremen that really actually daily use this stuff. So it seems it can be made to work in Bremen. Now, as Klaus said, the critical question, of course, is scalability. To make this scale on a European-wide level, we need address coordination, we need to talk about DNS, we need some form of routing infrastructure, tunneling, we need to get Cisco to fix the bugs in the VRF functionality of the routers, and so on and so on. So maybe the approach we did in Bremen isn't quite what we want to use on a European scale. It would work, but it's really a lot of work. So within the TF Mobility, we discussed various approaches, and obviously all these problems on the last slide go away when you use a public routable address space for everything. Now the problem, of course, is if you use a public routable address space, how do you get out of the docking network only to the right boxes, to the VPN gateways, but avoid opening your docking network to the entire world, because in that case you have 0 security left. So the hard part about making this work is to find a way to control the address space that is being used for the gateways. In our RFC 1980 world, that was very simple, because we knew we are now never going to connect these boxes to the internet. So it's very easy to maintain the security boundary. In a publicly routable world, it's a bit harder. So we came up with a concept that I am calling the Controlled Address Space for Gateways, or CASC. Uli has, in his original contribution that invented this, called this a relay network, but I don't like this term because it's not a network, it's an address space. So we should have a name that says it's an address space. And the idea is that the docking networks allow packets out to and in from the controlled address space. So you need to deploy something additionally in order to have these packets go in and out. But that's essentially all you need to do. And by the way, we are solving a little problem that we have in Bremen. In Bremen, somebody could actually use the Wbone as a transit network. And this approach nicely avoids that. So the result is we have these VPN-style institution networks. And we add an access controller, which is probably just a router with an ACL on it. And the access controller allows the docking network to exchange packets with this controlled address space for gateways. Now, this controlled address space for gateways is managed in such a way that it contains addresses for all the VPN gateways that want to participate. So the VPN gateways use additional addresses, use forwarding, whatever. There are many ways of doing this. to have legs within this controlled address space. And the rest is just a little matter of extending router configurations. I'm not underestimating this, but we think after talking with people that it's quite manageable. So how do you manage this controlled address space? Well, of course, we want to go to RIPE and get a /8 for this. Not quite. But we did a back of the envelope calculation looking at existing networks. And it looks like we probably need one address per about 10,000 population. So looking at Bremen, we need about 60 addresses. The country of Switzerland maybe needs about 600. That essentially works out. And if you assume that Europe is about 600 million people, then you need about a /16. And you can start to carve up this space using minimum routing fragmentation and so on and so on. Within an institution, you can either only use the cask address for your VPN gateway, or you can also just give it a local address as well if you have to do some routing gymnastics otherwise. So this is manageable. It is additional administrative work, but setting up a VPN gateway always is administrative work, and this just adds one step to it. So the most important slide. What is the approach for interoperability? Now that we have an architecture that allows us to roam within VPN systems on a European scale, how can we actually make the various approaches interoperate? Well, the first observation is that both the web approach and the .1x approach use a radius hierarchy. And we can just make sure that the radius hierarchy we set up works for both. And we actually can set up VPN gateways that also use this radius hierarchy. So there is a good way to make common use of an authentication and authorization infrastructure. VPN sites probably want to add some web-based filtering to their systems just to easily accommodate guest users that may not have VPN software on their computers. So VPN sites already have a certain incentive to do something that would allow them to interoperate easily with web-based filtering. Web-based sites already have access control devices sitting in the networks. These things, they already have them. And it's usually extremely easy to configure the things to add access to the controlled address space. So it will be very easy to get the web-based sites work for VPN users. And by using the radius hierarchy, the .1x users actually can log in at the websites. They will lose all the security, but they at least can log in. And finally, the .1x sites, which are a little bit more difficult because in a plain .1x site, you only get in if you can authenticate. .1x sites can buy the right equipment, like Cisco 1200, and add a docking VLAN, which is the place where all unauthenticated stations are put. And in this docking VLAN, they can do things like controlled address-based access and web-based filtering. If they want to do that, of course, that's actually additional work. So at least it seems doable, and the next step, oh, that's really fast. Okay, it seems doable, but of course, one never should underestimate the political problems. And let me close with a political slide. I have convinced you that it makes a lot of sense to support all three access control schemes. Now, this is a good time to actually forget that again, because your National Research and Education Network is quite likely to want to convince you that one scheme is the right scheme. And it makes a lot of sense for them to do that. Because the interoperability I just had is painful. So, for instance, for the Netherlands, it makes a lot of sense to standardize on .1x and be done with it, because it makes roaming so much less painful. And for Germany, it's probably a good idea to stick with VPN, since we have rolled it out in something like 50 universities. And probably for Finland, it makes sense to stay web-based. So on a national level, it's probably a good idea to standardize on one scheme. And then, of course, it becomes a little bit strange after I have convinced all my system administrators, you must deploy VPN, to tell them, by the way, can you open a backdoor for the .1x and the web-based people? This may somehow undermine my position. But I think it's still good to do the right thing here and to actually do the necessary steps to get interoperability on a European scale, because at the end we are trying to establish the European research area here. Thank you.
Thank you very much, Carsten. I won't take questions because we've run over quite a long way. I'm sure you can catch all of the speakers during the next half day and ask your questions then. And Klaus is going to show you the SurfNet solution if you want to see it next. So thank you very much to all of the speakers. Very interesting presentations. And can I remind you, the next sessions are started due at 11 o'clock. Thank you.